In this video, we're going to go into more detail about oxidation numbers for practice. So by the end of the video, you should be able to determine oxidation numbers of an atom in a chemical reaction. Redox reactions, electrons are transferred from one species to another, and it can cause a multitude of outcomes. This would explain why things rust, why things rot, how batteries work, or like the Statue of Liberty, why it turned green over time. So the oxidation states are really important for explaining those reactions, and to follow the flow of those electrons, we had to assign oxidation numbers. They're in the top right corner of every element's box, and the most common charge is a top charge. So the rules for oxidation numbers were an uncombined element that's not in a compound has an oxidation number of 0. They didn't write 0 in every single thing's box because it's understood that if it's not reacted, it does not have a charge. So like in calcium, if it's alone, it's 0. If it's chlorine and it's alone, it's 0. In calcium chloride, it's no longer 0. In the compound, it will have the charges. So again, the rules for oxidation numbers where the elements and the compounds have oxidation numbers listed on the periodic table of elements. For nonmetals, always use the negative top oxidation number. So like group 1 had a +1, and group 2 had a +2, group 17 had a -1, and so on. You can read them on the table, right, in each top box. In an ionic compound, the metal is always positive and the nonmetal is always negative. We always write plus, then minus. So we always write the metal first and then nonmetal, the same way it's organized on the reference table. So in the example of sodium chloride, we see a lot. Sodium is +1 and chlorine's top charge is -1, and that's why the example is just 1 sodium for every chlorine, because the charges will equal 0. The sum of the oxidation numbers in a compound must equal 0, so you have to make sure you multiply the oxidation number by the number of atoms in the subscript. So if they tell you the example is calcium chloride CaCl2, that's because calcium is +2 and there's only one of them, and chlorine is -1, but there are 2 of them, and then 2 plus and 2 minus equals 0. So that's why there are 2 chlorines in calcium chloride, because of those charges. At this point, you should be able to assign and identify oxidation numbers, which is really just the charge of each portion inside a compound, or if they're an element, it's always 0.